so continuing where we left off last time, we were talking about strings, and I gave a quick demo on some basic strings and string manipulations and told you RTM because there are dozens, maybe like 50 different methods that you can use in the string library to basically do anything that you want. One thing I do want to explain before we move on from strings though is how to compare them. Right, and you're familiar with this from C anyway. If you have two strings, char stars, right, and you say A is equal to B, then we'll print something out, or not equal to B. Does this work in C? I mean, it works in that it compiles and runs, but does it compare apples to bananas? No. What does it compare? Memory addresses, pointers. Same thing here. Let me change this to not if to show you that system.out.println not equal, right? And of course they're not equal because they're apples and bananas. But if I changed it to apple and apple, now I'm going to cross my figures here, and I'm going to predict that it's going to say that they are equal. Else, right? System.out.println equal, right? And I'm probably 90% sure that it's going to say they're equal, but not for the reason you think. It's not going to say that it's not comparing APPLE to APPLE. What it's doing is it's comparing the memory address of A and the memory address of B. Now you'd think because I declared two different variables, A and B, that they would have different memory addresses, and generally they should, but in this case the compiler was optimizing something for me. It realized you're creating two strings with the exact same content. I'm not going to double up on the memory. I'm going to create one apple and make A and B point to it, and that's why it's saying that it's equal. I will force the compiler not to do that for me by creating a new string explicitly. Now these two things occupy different memory addresses, right? In the Java virtual machine, and it'll say that they're not equal, even though it's both APPLE, right? Right? So, how do we go about doing this correctly? Right? I'll go ahead and change. I meant to do it oranges anyway, because that's how you really compare, right? Apples to oranges, right? You don't use not equals. You don't use less than because that would even be wronger, right? A is less than B won't even compile, right? You can't use the numeric comparison operators there. In C, what would you do? You want to compare two strings, so str, CMP, right? A and B. Do you remember? Did you use that? Right? And it returns an integer, right? It returns something negative if A comes before B. It returns something positive if they're out of order, and it returns 0 if they're equal. We don't have that. Instead, we have I'll say int result is equal to a.compare to B. I'm comparing A to B. That returns an integer result. Same pattern. That's called a comparator pattern, and it is used in every single language, period. If result is less than 0, in other words, it's negative, then system.out.println, I'll go with A comes before B. Right? There we go. And else if result is positive, then they're out of order, right? And so B comes before A, right? And the only other possibility here, after I correct my mistake up there, what's the only other possibility here? Result is 0. In which case, they are equal. A equals B, okay? Now in this case, which one comes first, apples or oranges? Apples, because A comes before O, right? What about apple and apples? Which one of those comes first? Apple, the singular, right? Good. That's dictionary order. What if I did something like this? Apple and banana. Which one of those comes first? Banana, why? Yep. Okay. So in this case, I should have done B. Right there we go. And now you're correct. B, banana will come before apple because the ASCII text table. Capital letters come before all lowercase letters. They're not interleaved. Right. So as a consequence, Capital B will come before lowercase a. It's not dictionary order. It's ASCII order, or we call that lexicographic order, right? Likewise, if you were to compare numbers, right? 123 and 9. Which one of those comes first? Well, if you're ordering things in a natural order and treating them as numbers, 9 comes before 123. But these are not numbers, these are strings. Consequently, 123, 1 comes before 9, the tie is already broken, and it outputs 123 becomes before 9. Right? So be careful, everything is lexicographic. Lexicographic order. According to the ASCII table, and if you want to, ASCIItable.com to remind yourself of what the ASCII table looks like. Okay? But otherwise, that's how you compare strings. Okay? Let's see. It's not open yet. Okay, so let's go comparing strings. Yeah, go ahead.
Just curious, what's a CSV file?
Oh, where'd you see that?
It was in what I forgot. I was watching a video or something.
Oh, it was like CSV data, or?
Sure.
Okay, well, the CSV data, we did that last time. Remember that it is data that is separated by a comma. So a CSV file is going to be, in fact, we're going to do it today eventually. We'll give an example where you've got the data and it's each line is one record, right? And each line is a CSV data, comma separated value. Right? In fact, I've already set myself up for it. There's a CSV file that we're going to use. I'll just look at it raw here, right? It's a book ID, title, last name, first name of a bunch of authors, okay? And we're gonna process that because the next one of the topics that we're gonna get to here today is file I/O. But before we get there, let's talk about methods and functions. So you are familiar with functions in say C, right? Technically they're called methods in Java, but I will use them interchangeably. Method, function, it doesn't matter. The technical difference between them is that a method belongs to a class. A function can exist by itself. And in C, you only have functions because you don't have classes in C. Right? You do have function pointers, but methods, because Java is an object-oriented programming language, belong in a class. The main is a method that you're already familiar with. We're going to start writing some other methods. Here's our first method that might help you for the first assignment. Public static double Euclidean distance. There we go. Right. So the idea here is that I'm going to give you 2 points. Point 1 is going to be at x1, y1, and point 2 is going to be at x2, y2. And I've just written my first function here, right? It's not compiling yet, but I outlined my first function. And this is exactly what you do in C, except that there are a couple of other keywords here that we'll talk about here in a second. This is called a function signature, right? That you have the return type, the name of the function, and then parameters, the number of the parameters, and then the type of each parameter. And normally in C, you would write it like this. That's a prototype. You'd put that into a header file. Then you would define the function in a source file. We don't have prototypes in Java. Instead, we just have the definition. We don't need prototypes because prototypes are a historic quirk of C anyway. They started out the language without prototypes, and then they added them back in because it was chaos, right? We want prototypes, right? All right, so there's our function. I'm going to restore now those 2 keywords there. What does public and what does static mean? Okay, public means any part of the code can see your method or function and thus call or use it. Right? As an alternative, you can use private, in which case only the class can see it. You can use protected, in which case only the class and subclasses can use it. That's going to come up later on when we talk about object-oriented programming. For now, just understand that all your functions are going to be public, otherwise you can't get to them, right? If a private method is not useful with the coding that we're doing so far, right? What does static mean? Static, did you use the keyword static in C? I don't usually cover it. Okay. If you didn't cover it, that's fine. It has a completely different meaning anyway. Static means that the method belongs to the class. Now, don't worry about that because that also gets into object-oriented programming. For now, just understand that the consequence of this is that you invoke the function, you call the function using the class name dot function name, right? Just like we did with the math library. Math dot square root, math dot sign, that's because all those functions were static, right? They belong to the class. And so now I've got my Euclidean distance here. I've not written the function yet. We'll come back to that. Let me go ahead and give myself some values here. Double x1 is equal to 10. Let's keep it simple. Let's keep it at the origin. Double y1 is equal to 0. Double x2 is equal to 1, let's say. And double y2 is equal to 1. And then let's go ahead and let's call it what it is, distance, right? Is going to be a call to Euclidean distance. But the way that I call that function is my class is called demo dot Euclidean distance. I pass in x1, y, oh, it already did it for me. Awesome code complete there, right? And system.out.println, what is the distance so far? Well, it's not compiling yet because we've not completed it. But that's how you end up calling your function once you've created it. Note that it's putting it in italicized here. That's also another visual cue that it is static, right? It belongs to the class. Now, it's kind of useless to put it into the demo class because the demo class is just something we've been using. So now you're probably going to want to get into multiple classes. For example, what if I were to put this into a class called, I don't know, distance utils, right? Short for distance utilities. Because if you don't know, Euclidean distance is not the only notion of distance. There's also the L1 distance, the L norm and stuff like that, right? You could have a Euclidean distance in 3 space instead of 2 space like this, right? So what I'm going to do is I'm going to transport this over to my distance utils, okay? And now when I do that, this won't compile because there is no Euclidean distance in the demo class. That's all right. Distance utils, right? Change the class that it's in. This is a way for you to start organizing your code. If you've got a bunch of utility functions, put them in another class. You can do that for your homework as long as it works on the grader. Yeah?
So this code, as it's written right now, you have public class demo, and then you have public static void. Then you have this method that's being called from distance utils
Yep.
class. Now, could you, in another code, write demo dot distance utils?
No. You'd have to, if you want the access to that function, you go distance utils dot, and because then it's independent, right? Basically the same as you would do math dot square root in any class, right? Just because I'm calling it over here doesn't mean that I now do demo dot math dot square root, right? It's as of now, it is an independent class with an independent function, right? A function inside of it, okay? All right, after you've done your signature, or maybe even before, the very first thing you should do with every method or every function before you actually write the function is write the documentation. Now, what we're going to, like we said before, we're going to expect author documentation, and author documentation belongs in the class, you know, me, the date, purpose, whatever. But if you start writing functions, every function, non-trivial function I should say, now needs documentation, right? So this is going to say it computes the distance between 2 points x1, y1, and x2, y2 using the Euclidean distance. Right? And I don't know what that is. I'd like to know or learn more about that, right? So let me go ahead and open up. Do I have a web browser open? Yeah, there we go. Euclidean distance, Wikipedia. There we go. All right, so there you can learn all about it. See also a href equals whatever here. I'll say that. Right. What did I just write there? What is this thing here? It's a link. It's HTML. I can embed HTML into my code. And when you hover over this, I need to fix it first, but when you, we'll look at it when we're done with it, but it'll actually render that HTML and have a little clickable link that you can bring up, all right? You don't need to put in HTML stuff in your code, but you do, for every non-trivial function, you need documentation at the top. And you need to use doc style commenting. That's going to be /**, followed by a vertical line of stars, */ at the end. And it goes above the function. All right, let's go ahead and create a result. Double result is equal to, how do I compute the Euclidean distance? Do you remember that from the handout? Or just from math, I guess? It's the square root. All right, fine. Let's go ahead and go back to Wikipedia. What does it look like? Right there, or there, right? The difference of x's and the difference of y's, each one of those squared, summed, and then take the square root, right? So math.square root of x1 minus x2 squared. So squared plus y1 minus y2 squared. Is that how you do squares in Java? It's not letting me, so no. How do I do squares? Well, a squared is nothing more than a times a, right? Okay, this part is not. This part, it has a meaning in Java, I should say. It's a bitwise exclusive OR operator, but that's not what you want, right? It's going to give you some weird value. Yeah?
There's no power function?
There is. So this is simple enough, though, right? That's the square, right? But if you want to, you can go ahead and use pow, right? And raise that to the power 2, right? And then it'll work, right? But that's kind of a sledgehammer for a finishing nail, right? Why use pow when it's just a square? If it were like 2.7, oh yeah, sure, certainly, right? I do need to use pow there. But if it's just 2, then just that is fine. Right? It's still not compiling because I'm not returning anything, so let me go ahead and return that result. There, now it works. Is this is this x1, this y1, x2, and y2, are those the same as these variables over here? Careful. No, why?
Because that's a different method.
Yeah, exactly. It's called scoping, right? This method has its own local functions. Then when we go over to that method over there, it has its own local variables, excuse me. This one has its own local variables, copies of it. In Java, everything is passed by reference. Copies of those values are copied onto the stack and then passed onto the functions. In C, you can do something like that, pass by reference, where you're passing the memory location of the variable, and consequently you could make changes to it in the function x1 dereference x1 and set it equal to 42. You can do that in C. You can't do that in Java because we do not have pointers. That's what that is. That's a pointer. Right? Okay, good. Do I really need to create this result variable? Can I get this a little bit shorter? Just return that expression right there. Perfect. Right? There's not getting any simpler than that other than reformatting it so that it's all consistent. Right? And what is the distance from the origin to 1, 1? Square root of 2, which would be 1.41 something, something, something. Right? That's why I chose that test case, because I knew up front in my head that it should be 1.41. Right? What's another test case that you could do really easily in your head? This is something you should have done already on your homework assignments. What's another easy test case? Like if I just go over 1 but stay 0 right there, do you even need to think about what the distance should be? Nope, it should just be 1 because of the way that I design the test cases. Do that, right? Design your test cases with the idea that I want to figure this out easily up front. Right? But otherwise, that's ad hoc testing, and that's a nice way to, as a sanity check here, to see if it's correct. Okay. All right. So, if you really want that, I can put that in the notes later on. But hopefully, you'd be able to. Hopefully, you already did it in your homework assignment. That's the first. It's the first exercise. Right? Otherwise, what else? You declare functions inside the relevant class and provide the definition, right? Documentation, signature, and function and definition are all together. As I mentioned, all functions are passed by value. That is, let me increase the size there. Unless they are objects, they can be changed. Then changes to the objects and method are reflected in the calling function. Okay, I maybe shouldn't have. I'll just leave it as pass by value, right? You all know that from CS1, right? Pass by value, pass by reference. Okay. Generally, you should use lower camel casing for method names. Right? Method names should be verbs, right? Because variables are nouns and methods do things, so they generally should be verbs. I didn't do that over here, but you can easily change any noun into a verb by just saying get, right? Get Euclidean distance, or compute Euclidean distance, or whatever, right? Okay? But those are general things that you should do, right? All non-trivial methods require Java doc style comments from this point forward, right? And unlike C, you can have multiple functions with the same name. In C, how many absolute value functions are there? Abs, fabs, labs, lalabs, right? Integers, floating point numbers, longs, longs, right? There are maybe there are even more than that that I'm not even thinking of right now. But in Java, they're all called abs, math.abs. Look at that. I've got 1, 2, 3, 4 different functions of the same name. They're all abs. They just take different types: double, float, int, and long. That's because in Java we have something called function overloading or method overloading. Java supports method overloading. You can have multiple functions of the same name as long as they take different parameters, right? Different parameter types or different number of parameters, right? And that's actually, that's an object-oriented programming thing, which is why C doesn't support it. C predates OOP. C++ has it, C# has it, all the variants of C have it, but C does not, okay? And it takes the guesswork out of that. It allows you to not pollute the namespace so much, right? You might have heard that term in CS1. When you create a function called foo, you've polluted the namespace. No other function can be named foo. So if you had two libraries that you wanted to bring into your project, and one of them had a function named foo, and the other one had a function named foo, now you've got a library conflict, and you've got a huge headache, right? It is resolvable, but again, it is a huge headache to do so. But over here in Java, no, put them into different packages, put them into different classes, put them use method overloading, and you can have 50 different functions named foo. They should probably none of them should be named foo, of course, right? All right, so yeah, go ahead.
Suppose you created a class, and in that class you create a method.
Mm-hmm.
Let's say Euclidean distance, and then it has certain parameters. And then in the same class you create another method called Euclidean distance with different, say, integers as the parameters.
Good.
So that would work, but what would happen if you would, say you create two same name, same parameters with two different functions? What would happen then?
All right. And let me just return 0.0 so that it compiles there, right? Now, the exact same one, but won't compile, right? It doesn't compile. It won't compile because the compiler cannot disambiguate between these two functions. In fact, this question came up yesterday in the separate section that we were using Python, and what would happen if I did this, and we did it, and it ran. What happened was that the second version overwrote the first version. And so different languages will have different quirks like that, but thankfully in Java, it doesn't even allow you to do this. Yeah?
If we had these two functions exactly the same, but in two different classes.
Oh, that would be perfectly fine. There's our Euclidean distance there, but then in a completely separate class, that's the Euclidean distance. Because you have to say, I want demo.Euclidean distance, or I want demo dot, or sorry, distance utils dot Euclidean distance. Yeah. So once you've separated them out, they're in different classes, they're different scopes. So you can do whatever you want then. Good. All right, so you did file IO in CS1 with C. All right, you remember you have to fopen something for either reading or writing, and then you have to process it line by line. If it's output, you're going to print fprintf maybe. If you're going to read something in, fscanf, or better yet, fgets or fgetc. Ring a bell? Okay. So in file IO, involves opening a file, operating on a file, processing it, and then closing a file. Exact same steps in every language, right? No difference over here in Java. Let's open a file. Well, first of all, we need a file. File f is equal to new file. And here we're going to give it the path to that file. So what I'll say is, generally what you do in a Eclipse project is you create a new folder, and then I'm just going to call it data, because that's what you're going to do in your project eventually. And we're going to open up data/input.txt. Okay. There is no file there yet called input.txt, but otherwise that otherwise creates a file. It doesn't open it up for anything yet. Let's open it up for the purposes of writing. Right? There are about a half a dozen ways of doing this. I'm going to show you the simplest and easiest. A print writer, right? PW is equal to new print writer. Well, print writer, what are you going to print to? Not to the printer, a dot matrix printer or whatever, right? Does anybody use printers anymore? Do you have access to printers? Right? Do you get free prints, or do you have to pay?
I think they're free.
Okay, up to a certain amount, I'm sure, right? But like, who prints stuff anymore, right? It's 2025, come on, right? Unless you absolutely have to or something. I guess I have to print my taxes soon, because I do send those in, right? All right, so there's my print writer, right? Now, if I were to actually print something there to the file, it would work, but it won't compile yet, right? This gets into something that we'll talk about a little bit later on, maybe next week or maybe at the end, called exceptions. So if you tried to open a file that was system owned in C, right? You tried to file open the password protected file. Is it going to let you open that? No, hopefully, right? So fopen would end up returning a null pointer. Right? Then you would check to see if that that pointer is null or not, so that you can write or read from the file. You are looking before you leap. Is this a valid file? Is it not null? If so, then I can go ahead and write to it. If it's null, that means something happened and I should issue an error message and maybe quit or something. It's completely different in Java. In Java, it says, go ahead, try whatever dangerous things you want. If it so happens that there's an error, we will throw an exception, a file not found exception, that you can catch and then decide what to do with it. Okay? This is just auto-generated code here, so I'm going to go ahead and get rid of this to-do here. Let's go ahead and print writer, there we go. It's a new print writer there. But now we can go ahead and print to it. pw.println, hello, hello, world. There you go. Remember that println is going to print a line. And this is why I showed you print writer, because you know println, system.out.println. You also know print without an end-line character. Hello, goodbye, world. There's no end-line character that's going to be there. And then finally, pw.print f, right? Your old friend printf from C. If you want to, you can do an integer, a floating point number, and maybe a string, right? And so this will be A, B, and C. I need those variables though. So int A is equal to 42. Int B is equal to 3.14159, and, or not int, but double. And string name is equal to me. Right? It'll format all those things, ABC, sorry. Right? It'll format all those things and dump it to a file. Print writer automatically opens the file for you. So open a file, process a file, output to a file. What's the third step again? Close a file. pw.close. Failure to close a file 9 times out of 10 it'll save you from yourself and it'll close it. It's that one time where you're actually running something that you care about that it will die and it will not automatically close it for you and you will lose data. Right? So make sure that you are opening a file, processing a file, and closing a file immediately afterwards. Right? Let me run this. Right? Still not satisfied because there's no file over there. Sometimes things need a kick in the butt. Right click, refresh, and it actually was there the whole time. Right? It's just that this file editor over here didn't see it because there was a new file and it wasn't told to flush and check for that new file. Yeah?
So when we created that folder, we didn't create this file. How did this file, when did this file get created?
It got created by the print writer. So if it did not exist before, it will exist now. Same thing with Fopen in C. Okay? Because we don't care that it exists or not because we're going to create it so that we can write to it. Right? If it existed before, by the way, hello world, let's go ahead and go with three there, end the line there, and let's also end the line there and do something else there. I'll move goodbye down there. Right? Now what happened, there's the original file. What do you think that is going to happen to that data when I run this again? It's going to overwrite it. And it is all gone. And it's gone forever. No undo, no recycle bin, nothing. Right? So you've got to be really careful with what you're doing. What if I tried to open up, let's go with source uno ece demo.java. All right. So I'm going to copy things first. Let's run this. Okay. What did I just do?
Replace your program.
Exactly. Right. And now I'm screwed because I lost all my code. Right. That's why I copied it first. You could also do undo, I guess. Right. So there we go. And let's go ahead and restore this down back to something input.txt. Be careful. If you open up a file for reading and you accidentally open it up for writing, you ain't gonna read it. It's gonna be gone now because you've written to it and you've overwritten it, right? Same problems with Fopen. Oh, and it's in the data folder here, okay? Let's go ahead and run that one last time just to make sure that it's all good. Great. So that's the easiest way of doing file output, right? PrintWriter is your friend because PrintWriter has println, printf, and print, all things that you're already familiar with. And you don't have to worry about flushing data. You don't have to worry about anything that you'd have to worry about with respect to you use fprintf in C, right? Something like that. Anything that you'd have to worry about there. Coming back to this though, what if it didn't find it? It's kind of stupid because if it didn't find the file, it creates it, right? Of course, it's always going to find the file because that's the point of the print writer. It's going to create it. So why the heck does it throw this thing? It throws this thing if permissions are denied. For example, what if I was trying to create a file that already existed that I did not have permissions to overwrite or read or do anything with, right? For example, the etc password file. Etc is for etc, and any Unix system, I am on a Mac, which is technically BSD Unix, right? BSD Linux or whatever. And there is a password file somewhere in there in the etc folder. Should I be able to overwrite that? Probably not. Let's go ahead and see if I can. We could really screw things up if we can do this, but let's find out. Yeah, there we go. Oh, first of all, it's checking, thank God, right? I am the administrator on this computer, so if I gave it permission, it probably could do it. I'm not going to allow it to do that because I do not want it to screw up any files, so don't do that. What happened? Operation not permitted, file not found. Stupid, right? Operation not permitted is a completely different error than file not found in my book. We will learn very, very quickly that these kind of exceptions were dumb. They were a mistake 20 years ago in Java, and they've never officially admitted the mistake, but the people who put it in there are probably long gone anyway. But everybody recognizes this is a mistake, right? That these are called checked exceptions that you are forced to surround with a try catch, okay? So what do we do with that? Well, we could just print the exception and move on, What I like to do is what's called catch and release. Anybody like fishing? I don't fish, but what is catch and release? You catch a fish, yay, look what I did, and then what do? You throw it back in. Or maybe it's not a good eating fish, and you accidentally caught something that you shouldn't have, and so you throw it back, right? In any case, all the so-called lakes around here are, you should not eat the fish anyway. Most of them, at least. They're all like runoff and flood control areas that you don't want to be eaten out of. So what I'm going to do is I'm going to catch and release. I'm going to rethrow that exception. New runtime exception, right? E. There we go. All that does is now when I can't open this up, don't allow, it rethrows this file not found exception as a different type of exception. Oh, this is called an unchecked exception, and this is what all exceptions should be. So we're fixing Java's mistakes from 20, 30 years ago. Right? Anytime you have a checked exception, we'll talk about that in more detail later on. We're just going to rethrow it. Okay. All right. So that's file output. Really easy. Just use, again, there are like a half dozen other ways of doing it, file output, but just use a print writer and you'll be good if you ever need to. I don't think any of the assignments, none of the assignments that we have for, assignment 0 is not going to require that, but future assignments might. And then the opposite of that is going to be file input. Okay. Now the best, again, there are a couple dozen ways of doing this. I'm going to show you the easiest way. And to do that, I need to add some actual data. And for that, I'm going to grab maybe the first couple of lines of this file right here. Right-click this, new file, and I'm going to call this books.csv. It's a comma-separated value file, as you asked about before. Right? All right. Now, you'll see over here this icon is telling me, and in fact, it's probably trying to open it with Excel. Because Excel, come on. Wow. All right, yeah, it is opening up Excel. That's why it's so slow. I don't know why. But anyway, it tried to open that up over here in Excel. I don't want that, right? I don't want to work in Excel. This is not Excel data. This is plain old CSV data. Right? So what I'm going to do is I'm going to drag and drop it over here. And now I can just treat it as a text file and start mashing my keyboard. I'll go ahead and copy over the data that we had over there, though. And let's go ahead and zoom out here. The first line is going to be a bunch of headers, right? The first column of this, if I were to open this up in an Excel file, the first column is a book ID, right? The second column is a title, so here 13651. This is data from Goodreads.com. The Dispossessed, an Ambiguous Utopia, right? That's the title. The last name of the author is let's get rid of that one because I think that's bad data. Right? Here we go. Paddle Your Own Canoe, One Man's Fundamentals for Delicious Living by Nick Offerman. First name Nick, last name Offerman. There's an ISBN 13. That's a unique way of identifying a book. Right? There is a Goodreads rating. Right? That's the average rating of all people who have read that book and rated it. Then we've got the publisher, the original publication year, and then the date that apparently I read it, right? So last year sometime. Right? No, 2 years ago now. Last year, yeah, last year in November, right? We're in 2025 now, right? So this is typical CSV data, and this is CSV data that you'll be processing in both your assignment 0 and in your project, right? So how do we go about, first of all, reading this file, okay? What I'm going to use is something that we're familiar with already, and this is why it's the simpler way. Scanner, new scanner. And I need a file first. File F is equal to new file, and it's called, what did I call it? Data/books.csv. That creates a reference to the file, but it does not open it. The scanner will open it for the purposes of reading from it. Right? We saw this already with scanner if we did system.in. That's how you can read interactive input because the keyboard is actually a file technically. When you type on the keyboard, those characters are put into a file, a buffer in memory. It's just not a file that's on disk. It's just a file that's in memory. So it's actually reading from an output, an input stream here, a file, right? Once I've got that, I could start saying, okay, f dot get, or what is it, got get line, or sorry, not f, s dot next line. And I can store that into a string, or let's call it line. Right? And then let's print it, system.out.println line. There's the first line. There's the second line. There's the third line. Right? I can't have 3 variables of the same name, so I'll just reuse the same variable here. Same problem as before. It's not going to let me compile because this is required to be around a try catch. In fact, I'm going to move all of this up here into the try. Oops. There. Again, I do not like printing stack traces. Instead, I'm going to rethrow this as a new runtime exception. We'll go into detail on that later on. But otherwise now it's okay because I'm going to try to open it. If that file does not exist, then it'll throw an exception. In fact, let's go ahead and misspell books to show you that it will throw an exception there. Yes, go ahead and save everything. No such BKS, it does not exist. So it throws a file not found exception. Yeah?
So if we were, instead of trying to trying to get information from a file, if we were trying to write to a file and we typed in books misspelled, would it create another file?
It would create a new file, yep. As long as you have permission to create that new file. Again, if I'm trying to open up the password file or overwrite the password file, no. Unless I click that allow button, and I'm not going to do that. That would really screw up the system. All right, so what are you complaining about here now? Oh, good. You're complaining, what does it say? Resource leak. S is never closed. Remember the 3-step process. You open a file, process it, and then you close it. So let's close it at the end here. And we end up closing s.close. Okay? Let's run it now with the correct file name, books.csv. There's the first line, the second line, paddle your own canoe, and then Killing Commendatore by Murakami. Right? Those are the first 3 lines over here in this file. Now, I don't want to copy, paste, copy, paste, copy, paste, because I don't know how many lines are in that file, right? I can't ask the scanner how many lines are in that file because it doesn't know. It's just scanning, right? It would have to scan all the way to the end in order to tell you, oh, I read 50 lines there, right? And then it would have to go back to the beginning and start over in order to start processing those lines. So instead, it gives you another way of doing this by asking, is there at least one more line? While s dot has next line. Right? While it has another line, go ahead and grab that line, oops, grab that line, print it out, and then once you're done, close it out. So while you still have another line to read, go ahead and get me that line and then print it out. There. So Death World 3 and Death World 2 look like the last 2 lines to me. Careful. What if you have a bunch of blank lines? There, it's going to print a bunch of blank lines. Right? So if you're going to end up processing this data, you need to ask yourself, is it a valid line? Right? If line dot, or actually no, we'll get the line, and then we'll say if line dot is empty, right? Is not empty, then we care about it, right? We care about it enough to actually print it out. There. And there. No trailing blank lines because we've already asked, is it empty? If it's empty, and these lines are empty right here, right? They have an end line character, but empty ignores that. In fact, I think scanf actually strips those out for you, right? Scanf will strip out the end line character is what it gives you the next line. So since it ends up being empty, we end up ignoring it, and we only get the valid ones, right? In fact, let me add one down here, foo, right? At the very end, I've saved that file, and you'll see here that all those blank lines between the last record and foo are ignored, okay? Of course, foo is not good data, so I'm going to go ahead and get rid of it. Any CSV files we provide, you can assume that they will be well formatted. In other words, there are 9 columns here, if I recall, right? Every single one of these records will have 9 columns. You will not have a case where we insert a bunch of blank lines just to trick you and then have some extra records at the end. You can assume good data for the most part. Okay? And if there's ever bad data, let us know because we need to fix that. All right. So, how would we go about processing each one of these lines? I want to know what the best book was. What was the best book that I read last year or whatever, right? Or that's in my collection here. Right? Among these 28 books, yeah, go ahead.
Would you create a list for every column that basically as it goes through, if it finds a greater, say you make a list
for the average rating, good.
For the average rating, create a list, and then as it goes through, it takes the first line, it takes that average rating, plugs it into a variable or the list. Or I guess you can do it. I guess you don't have to do a list. You can just do like a variable that takes.
Yeah, the max or something. Okay. So let's go ahead and say that let's say double max rating. I'll go ahead and start it out at 0.0 because I know that there's some books in there that are greater than that. All the books are good. No, there's no such thing as a 0.0 book, right? But now down here, if I've got a line that's not empty, I have to get that, let's see, 1, 2, 3, 4, 5, that 6th column out of there, right? So this is CSV data. How do we process that one line? Yeah, and how did we parse it last time? There's CSV data. We split it using a comma, right? That will give me a bunch of tokens, okay? So let me grab that code there. Right? That's not CSV, the line is CSV data. Right? We're gonna split it. Now I've got my tokens. Which token am I interested in? 0, 1, 2, 3, 4, 5. The 6th token is at index 5. So tokens, so 5. Right? Can I compare that to max rating? If that's greater than max rating, is greater than max rating. Yeah, update max rating to tokens, so 5. It's not letting me compile. Why? Tokens, so 5 is a what? String. Max rating is a double. So how do I convert a string into a double? Double dot parse double, right? And tokens. There we go. And since I'm using it in 2 places, I'm actually going to move that out. Double rating is equal to that. So that I can use rating both here and here. Okay? Yeah. Go ahead. No, you can't do that. You have to parse it out. Right? You couldn't do that in C either. You'd have to use A to F or A to I. There are some languages that let you do it. JavaScript would allow you to do that. Python wouldn't let you do that. PHP would let you do that. But the languages that let you do something like that, it's kind of chaotic. What happens when it doesn't have a number? It ends up being 0. It ends up being exception. It ends up being fatal. I have no idea, right? I take the guesswork out and always be explicit in your code. Yeah.
Suppose you wanted to use all this information later on.
Yeah.
Would you just then create lists of every single one of those sections?
Yeah.
Store it there, finish the whole while has next line, or should close out the file, and now you have these lists of data.
You found the problem with approaching a problem piecemeal like this. I only have one piece of data. In fact, let's go ahead and find out what that best rating is. System.out.println max rating. I think we're going to get an answer here. Oops. Average rating. Oh, okay. Good. What did we forget? What's going to happen on that first line when I try to treat the word average rating as a double, adding a double? So because we've got headers here, what we need to do is we need to skip the first line. So let me just go ahead and say s dot next line, and what I'm going to do is waste the first line, right? Before I even get into my loop, okay? Waste the first line, which is header data, okay? Column data, like the column heads, right? Now it'll give me a, there, 4.35. Does that tell me what book is the best book? No. Does that tell me who the author of the best book was? No. It doesn't give me any information because I am approaching this piecemeal. I'm only pulling out one piece of data. Now you're right, and like, what if I wanted to do the worst book as well? Right? I'd have to have two variables. What if I wanted the average of all of them? Now I need a list. So approaching this problem a little bit more generally, instead of a double one max rating, let's go ahead and go with a double, actually a list of doubles. Double equals new array list of doubles, and I'll call it ratings. Right, there we go. Now instead of comparing a rating and just concerning myself with one value, let's go ahead and add that, ratings.add rating. Right. Now at the end here, I have all of the ratings. Right? Let's go ahead and print out all the ratings. If I were to sort this, ratings, excuse me, there we go. Then I would, if I were to sort this in ascending order, I would have my answer down here. In fact, let's do that really quick. We'll show that eventually, but collections.sort ratings. There we go. It's easy enough. We can just do it really quickly. There's the best book, 4.35. There's the worst book, 3.38. I could take an average because now I have all the data. Right? I could do anything I want with this data now. I could find the mean. I could find whatever regression there is, whatever, right? But it's still not satisfying, right? Because, as I said before, does it tell you who wrote these books? Who wrote the best book? Who wrote the worst book, right? So we could have a list of strings that are author's first name, right? A list of strings that are the titles, right? A list of. That doesn't sound like a good idea either, though. Yeah.
Off topic, but I thought I remember you, because I'm still a little confused about the new thing.
Okay.
I thought, so like the way you have it written right now, would those first two declarations be valid, or do you have to initialize?
These are, I mean, this declaration right here is valid, but as you can see, it's warning me about it that it's uninitialized. If I were to do anything with it, author, let's do a title because it's shorter. Title.add, hello. That's going to end up being a compiler error because I can't add something that to something that's not initialized. If I explicitly say that it's equal to null, which is the default there, then it's going to be a null pointer exception. You have to create something new in order to put stuff into it. Right? And if you don't, you're either going to get a null pointer exception, or in the first case, it's not even going to compile. Yeah.
Just one more question.
Sure.
So when I was like messing with some code, like I found I can create variables, new integer equals something, and I tried typing in new. I thought that's what you have to do to initialize. When do you have to initialize with that word?
Okay.
And when,
Yeah. If you did something like this, no, that's called a primitive type, lowercase I. It's purple, and it's a lowercase I int. Right? You don't have to initialize primitive types.
Okay.
When it's a class, like a string, that's a bad example because you can do it with a string too. But when it's a class, like a list of strings, you have to initialize it with a new. Equals new array list. There. So if it's an object, it should be initialized, or it has to be initialized. But when it's a double y is equal to 4.5, char initial is equal to c, right? Those are all primitive types. They're all lowercase. They're all purple. You don't need to initialize them. And the reason is they're built into the language. The language knows how to initialize those, right?
May I ask one last
Yeah, sure.
So you have list string author's first name equals new array list. Is that array list it's a method?
Technically it is. This is called a constructor. That's something that we'll get into later on. But that is a constructor, and I can show you what it looks like. All it does is this lists elemental data or element data We're just going to go ahead and default capacity empty. What is that? There. Okay, it's nothing. It's empty, right? It's nothing. It's an array of nothingness, right? And that's why it's an empty list. And then now you can start adding stuff to it, and it'll change it. Right? Yep. Good questions. Right? But it does take a much deeper dive to appreciate that, right? To see all that stuff. So I want to answer the bigger questions of who wrote the best book, who wrote the worst book, what was the title of the worst book, et cetera, et cetera. If I wanted to do that, I would have a list, right? In fact, I would have 9 lists, one for each one of these pieces of data. That doesn't sound right to me, though. Right? Would you do this in C? Would you have like 9 arrays of data? I want to, this data right here on this one line, that should be collected into one thing, right? That gets into encapsulation. Right? What did you do in C to encapsulate that into one thing? A struct, right? And in Java, we have classes. Oh, before we do that, let me go ahead and copy this over. Let me go ahead and get rid of this, right? And I'll copy this over into the notes so that we don't lose it. Right? But otherwise, that's what I want to work on next, classes, okay? Classes in Java allow you to encapsulate more than one piece of data into one logical unit, a class, right? Classes also allow you to include functions, methods that act on that data or process that data, okay? So, what am I trying to model here? Remember, one of the fundamental questions that you should ask yourself at the end of the course when you approach a problem to solve is, what should I create in order to model this problem? Well, my problem is I want to know what the best book is. So what do I want to model? A book, right? Let's go ahead and create a class that represents a book. What should I call that class? What does it represent? A book, right? There we go. It's a book, right? It's not books, right? Books would be like a collection, like an array of books, of book objects, or a list of book objects, right? It's singular, okay? Public, class, book. And then we have an opening curly bracket and a closing curly bracket. Up to this point, we did like demo class or a utility class. Now we're actually going to do a class that represents something. So how do I represent a book? With those pieces of data. Right? So what is a book ID? If you look at the data, what does it look like? Looks like an integer to me, right? So let's make it into an integer. Int book ID. Right? Title. String title. Right? First name. Last name. Wait a second. Okay, let's come back to those two. All right, what about ISBN? There's an ISBN. There's another ISBN. Those look like integers to me, but how big are those integers? Right. Let me go ahead and add commas here so that we can read it. There we go. Is an integer going to be able to hold that ISBN? No. All right. String ISBN. Right. There, solved. Right. By the way, there are other ISBNs with hyphens in them. Or say a social security number. You could probably represent a social security number using an integer, but guess what? Social security numbers have hyphens in them, right? They have separator values. Same thing with a phone number. Same thing with an NUID. There aren't that many people in here, but maybe one of you at least has an NUID that begins with a 0. There are people like that. And there are, in fact, people that begin with 2 zeros, right? Is an integer a number that begins with a 0? No. So those are probably strings too. Average rating, double. I'll just call it rating, under knowing that it's an average rating. Publisher, What kind of data was that? Penguin Books. String. All right. Publisher. Original publication year. I'll just call it year. Actually, I'll leave that blank for now. And then the date that I read it. Okay. String. Okay. So let's come back to all of those one by one. Let's start back up at the top here. There's some things that are obvious. ISBN, book ID, etc. What about the author's first name and the last name? Strings, right? String, oops. Author, last name. String, author, first name. But it's kind of bothering me. Why are we writing this book class to begin with? Because we had 9 pieces of data that we wanted to collect into one object, one thing. Last name and first name? That's 2 pieces of data that seems like it's the same author, right? So what do you think we should do? Make it one. How? By creating another class to represent an author, which would be a person. Okay. And a person has a string first name, string last name. And then we can start expanding on that. Even though it's not part of the data right now, maybe they've got a birth date, maybe they've got a social security number, maybe they've got a telephone number, an email, or multiple emails. We can start putting that stuff into this class. But now over here in the book, now that I've done that, I can say person, author, right? Once you create a class, you can start using it in other classes. Right? If this is the author, and what are they? Well, they're a person. Well, what is a person? A person is a first name and a last name, and maybe more later on. Right? We'll come back to it. Okay. All right. Thinking along those lines, publication year. That might be obvious. That might be an integer, right? Publication year. Right? Okay. Did I write it? Publication year? Okay. Now, what's the risk there? Is my program going to be useful after the year 2.57 billion? What's going to happen when somebody publishes something in the year 3 billion? Overflow, right? And we'll be back to the same problem as Y2K. Same problem as the Unix epoch in 2038. Any Unix clock that is still using a 32-bit integer is now going to go back to like 1800 or something, right? In 2038. So we're almost there. Right? You guys are going to have your generation's Y2K, right? You might not even have been born for Y2K the first time around, but you're going to have your own, right? And it's 2038 sometime. Right? Publication year. Okay, fine. I'll just go with an integer there. Right? The problem there is, well, what if I read the Iliad by Homer, published in like 700 BC? Negative 700. Okay, that'll work too. Right? All right, I'm satisfied with that. The date that I read it. Right? What is what? Yeah. Oh, good. Why? Because what is a date? Month, day, and a year. Right?
If you're talking about 3 billion centuries.
Yeah. So, and even if you go back, like our calendar is the Gregorian calendar, right? So if you go back like even 300 or 400 years, they didn't use our calendar, right? They used the Julian calendar, or if you go into a different culture, they use the Japanese have a different calendar based on their emperors. The Chinese have a different calendar, right? Every culture has their own calendar. In the modern world, we're all using the Gregorian calendar, though, right? So I could make it so that there were, say, a class with 3 integers. But the next question you ask yourself in engineering is what? I need a way to represent a date. So, or just make it generic. There's a problem that I need to solve. What's the laziest thing that you can ask? Be lazy, because that's what programming is all about.
See if there's a regular class.
Yeah, has anybody already solved this before? Right? And they have. Right? Local date, date red. There we go. That is built into Java, not built into Java. but it's in the java.time library. Right? There is no date in the java.time library because, like I just said, dates are subjective. Right? In fact, if you go halfway around the world right now, it is a different date right then and there. Right? However, here in our local area, that we can all agree on the date. Now, if you go to western Nebraska, you step over there's also local date time, right? But if you step over the time zone line, it all becomes subjective again, right? Also, maybe you refuse to recognize daylight savings time, so you're off by an hour or something, right? Anyway, that is a good start. The way that you design a class is you ask yourself what data is needed to represent this thing, right? And if it's an integer, then use an integer. If it's a double, use a double. If it's a string, use a string. If it's more than one piece of data, consider either creating another class or finding out if a class already exists for you that does the work for you, right? There is no pre-existing person class, by the way, right? Okay. So there is our initial design of the book class. So class design, let's talk about that. Class design. You break an entity, is what we call them, entity down into its parts until, right, ... You can represent it by a built-in value or type, like say int, double, string, or there are multiple pieces of subdata is what I'll call that, right? That's not really a word, but subdata, in which case you create a new class unless ... a class already exists to represent that thing or that entity. Right? Okay? This is why we call it object-oriented programming. What are these entities? They are objects. Right? They are things to think about and ultimately interact with each other. You can have a class. A class can consist of other instances of other classes. For example, our book class owns several strings and is composed of other classes. For example, the string is a class, local date, and person. Right? So this is called composition. Composition. Yeah.
So for the local date class,
Mm-hmm.
is it just a way to like represent a date with the year, month?
Yep, and the date, probably the day of the week too. If you ask it what day of the week is that date, it would tell you. It would not tell you anything about the time unless you expanded it out to a local date time. Now it's a date and a time, all the way down to like a microsecond. Right? So, question though, before we go on, how do you represent dates? So one way to do it is 3 integers, right? Int would be the year, month, and day. Right? What's another way of representing dates? Okay, so the order, you can change that. In fact, the best and the order is going to be the ISO 8601. Right? And give me Wikipedia, please. Good. ISO 8601. There it is. There is a date and a time. There's the date, though. Today's date is 2025 01/30. Right? That's the proper order. Year, month, day. Because if you were to order it in lexicographic order, right, with leading zeros, by the way, because if you were to order it in lexicographic order, it would all be in temporal time. Right? If you follow the American way of doing it or the European way of doing it, it screws everything up. That's why this is a codified standard here. But at the end of the day, how are you representing this thing? As a string. Right? That's another way. What's another way? I mentioned the Unix epoch. Unix epoch. Right. There we go. The Unix epoch was January 1st, 1970. The way that Unix represents time is with a number. Right? the number of seconds that have passed since that Unix epoch date. So that gives you the find 2038 problem. There we go. There's the 2038 problem, right? When you get up to 2.147 billion seconds since January 1st, 1970, then ultimately you're going to hit an overflow. Almost there, 3 more seconds. There, and it becomes 1901, right? So in 1938, some computers maybe are going to be kicked back over 100 years, right? Because of overflow. Hopefully they are using 64 bits instead of 32 bits by then, and you'll still have a problem though. 64 bits, that's going to be several billion years in the future. But those several billion years in the future, if they're still using our computers, shame on them. But then they're going to run into yet another problem, right? But that's the solution. Just add more digits. Add more digits. Right? That's the future's problem, right? But that's another way of representing it. Guess how this represents it. Before you guess, did you ever think about it? Before I said that there were 3 different ways of doing it? You didn't care, did you? Right? Likewise, when I ask, say, math.square root, darn, how does that work? How does it do a square root? Did you ever think about it? No, you never cared, right? That's because it's abstraction. Somebody figured it out and put it into a function. Somebody figured out how to represent a local date and put it into a class so you don't have to worry about that, right? If you really want to worry about it, you can go ahead and rip it open and find out. There's the Unix epoch, right? And there we go. How are they doing it? 3 integers. An int for the year so that they can support up to the year 2 billion, right? But a short, we haven't talked about shorts. A short is only a 16-bit integer for the month. Why? Is there any month with more than 31 days? No, and they ain't making more. Right? So you only need that much precision for a month. And a day, or sorry, there was only 12 months, right? 30 days is what I was thinking, 31 days at most, right? So that's how it ends up representing the year. But the whole point of writing a class is for abstraction, right? Okay? So another purpose of writing classes, abstraction. We don't want to have to worry about how data is represented. We just want to interact with it. Right? In fact, we don't have to worry about, now that we've written this book class, we don't have to worry about how it's represented anymore. If I want to create a book, book B is equal to new book, I can do it. Now I've got a book, right? I can start asking questions of that book. What's your rating, so I can compare it to that book's rating over there and get a comparison. You're the better book, you're the worse book. Were you written by so-and-so, right? Were you written by Nick Offerman? Yes, I was, or no, I wasn't. I can start asking questions of that book, but of course, then I need to start putting the question askers in, or answerers in this class here, right? And that's where we'll pick it up next week, because we've got a lot more work to do on this book before we can start doing answering those bigger questions. Remember, it's a bottom-up kind of approach to problem solving instead of top-down. How can we represent a book? Now how can we start using that to answer bigger questions, right? We're going to start at designing a book and then go back to answering who's the best book. Okay? All right. I'll see you in lab up there.